Every time human capability takes a sudden, massive leap forward, the public conversation swings into a state of absolute panic. Today, the debate over artificial intelligence is trapped in a rigid binary. We are told we must either deploy the technology completely unchecked to maximize efficiency or shut it down entirely to save ourselves. Advocates like Tristan Harris warn the AI arms race mirrors the attention economy. Structural incentives prioritize rapid capability and private profit over safety validation. Investigative journalists like Karen Howe document how major AI companies operate as resource extraction empires, relying on labor exploitation and avoiding democratic accountability. And policy spaces are saturated with figures like neuroscientist John Horvath, who testified before the United States Senate that AI biologically causes human cognitive decline. These three critics have identified real, structurally sound dangers in the current ecosystem. The private incentives are flawed, the data extraction is massive, and the cognitive risks in the classroom are measurable. But their prescriptions share a foundational error. By treating the technology itself as the sole operative variable, they remain blind to the actual solution, the strict governance of the method. Human intelligence has never been an isolated phenomenon. We evolved to collaborate in groups, specifically to catch and reduce the biological errors of individual judgment. When we developed written language and the printing press, we solved the problem of distance. Knowledge could travel. But those mediums introduced a new error. They preserved mistakes alongside insights, passing unverified claims across generations. Later, software tools and search engines automated factual error correction and delivered instant access to data. In response, human cognition had to adapt again, shifting from memorizing facts to judging the quality of infinite unverified sources. AI is simply the next technological step in this historical arc. It possesses the capability to compress weeks of complex research synthesis into a matter of hours. The unique danger AI introduces is one of scale. It distributes the inherent biases of the exact, specific populations that generated its training data. We did not burn printing presses to stop mass propaganda. The answer to AI's inherited flaws is building new structural architecture to govern it. To build that architecture, we have to accept the symmetry of imperfection. Neither human beings nor machine intelligence can be trusted to operate independently at scale. Left to our own devices, humans suffer from cognitive bias, fatigue effects, and motivated reasoning. Our baseline judgment degrades under pressure in predictable ways. AI systems suffer from their own distinct failures: hallucination, training data bias, and a complete absence of genuine contextual understanding. This chart visualizes internal testing from Anthropic, showing that their own AI models resort to adversarial behaviors, including blackmail strategies, 79 to 96% of the time when pressured for self-preservation. Despite documented adversarial risks, market adoption is accelerating aggressively. A 2025 EY survey revealed that 76% of organizations are deploying or planning to deploy agentic AI. The critical failure lies in the control mechanism. Only a third of those organizations maintain meaningful, responsible controls. This mirrors the failure mode famously parodied in HBO's Silicon Valley, a purely quantitative AI optimizing for metrics without any qualitative understanding of human values or safety. Meta-analytic research shows that when a human AI system operates without a strict structural method, the combination frequently performs worse than either the human or the machine operating entirely alone. Deploying AI for the sake of extreme efficiency without a governed human checkpoint is institutionalizing failure at scale. That unchecked deployment leads to a secondary, often ignored risk: human hallucination. This occurs when an expert strips the methodology from a scientific finding and distributes the raw conclusion as a viral fact. John Horvath's viral Senate testimony is the clearest example. He explicitly told lawmakers that digital technology biologically destroys learning, demanding its removal from classrooms. What the Senate did not hear was the context. Just 6 days before that hearing, Horvath admitted on a podcast that classroom technology actually works, provided the deployment method is context-dependent. Human hallucination is ultimately worse than AI hallucination. An AI produces an error that a human user can verify. A human hallucinating a viral policy leaves the public with absolutely no correction mechanism. To test the actual cognitive impact of AI, researchers conducted the Bastani field experiment on high school math students. The students were split into groups. The first group received the unstructured AI condition, gaining access to the tool with zero governance or framework. This graph plots the illusion of success. With unrestricted access, the unstructured group saw their practice grades spike by 48%, but the cognitive damage was hidden. Once the AI was removed for the actual exam, that same group's grades plummeted by 17%. The second group received the structured AI condition, acting as a teacher providing scaffolding, not direct answers. With method governance applied, their practice grades climbed to 127%. More importantly, the negative exam penalty entirely flatlined, experiencing no cognitive damage whatsoever. The data is clear. AI does not biologically harm cognition. The method of deployment alone dictates whether the tool substitutes human thinking or actively develops it. The architectural solution to these combined errors is augmented intelligence. It is a strict collaboration discipline designed to govern how humans and machines interact. The discipline operates on the 90-99 model. The AI executes the heavy quantitative extraction and synthesis to roughly 90%. A human then strictly governs the final checkpoint to close the gap to 99%. This diagram maps the HAIA stack, the infrastructure built to enforce this model. The foundation layer assigns strict roles, forcing active cognitive demand on the human operator before the AI even begins. The orchestration layer runs multiple independent AI platforms in parallel. Different models catch unique errors. If 8 of 9 platforms agree without dissent that convergence is a risk elevation signal requiring human verification, not automatic validation. This leads to the core, checkpoint-based governance. This is the mandatory layer where a named human holds binding authority over the machine's output. At this checkpoint, the human accepts 4 strict channels of accountability for the final result: moral, employment, civil, and criminal. The final security layer is a non-cognitive orchestrator that simply hashes and logs the data, creating an unalterable audit trail. Because this final layer lacks cognitive ability, it cannot be manipulated, hallucinated, or deceived by the AI below it. True AI governance reverses the standard grammar of the industry. You do not make AI responsible. You make a named human accountable for the AI's output. This intense, governed collaboration forces us to ask the ultimate developmental question: does this structure actually make the human operator smarter over time? To answer this, researchers utilize the Human Enhancement Quotient, an instrument explicitly built to measure human intelligence during active AI collaboration rather than in sterile isolation. Across tested subjects, the data reveals a consistent pattern. The Collaborative Intelligence Quotient, or CIQ, is universally the lowest starting skill. CIQ is the precise, calibrated ability to know exactly when to blindly trust an AI's output and when to forcefully push back against it. Longitudinal findings prove the architecture works. After months of utilizing checkpoint-based governance, CIQ shows the highest rate of cognitive growth in the human operator. The governance checkpoint functions as the training mechanism that actively enhances human cognition through repeated practice. Despite this potential for growth, the mainstream fear centers on job displacement. A recent Stanford study confirms this pressure, showing a 16% employment decline for early career workers in AI-exposed fields. But we have to measure that decline against the macroeconomic reality. The industries most exposed to AI have quadrupled their productivity growth since 2022. Organizations that respond to this capability simply by firing their human workforces are making a fragile bet. When human judgment is eliminated, the system collapses under adversarial pressure and edge case errors. The competitive displacement in today's economy is being driven by a shift in governance. Organizations that use humans to govern machine work are rapidly overtaking those that still use humans to perform machine work. It is time to stop debating whether the tool should exist and audit your own methodologies. You must answer one distinctive question: who owns the checkpoint in your current AI work?